Ever wondered why a rubber balloon sticks to a wall if rubbed on your hair? Or why a lightning bolt lights up the dark expanse of the night sky? The answers to these intriguing questions dwell in the world not visible to our naked eye. They reside in the realm of electrons, a world teeming with energy and mystery. Electrons are unimaginably small, so tiny that they're practically invisible even to the most powerful microscopes. They are smaller than the smallest thing you could possibly conceive, a world within a world in their own right. Electrons are crucial to the functioning of our universe. They are the lifeblood, the essence, the pulse that keeps everything ticking. Without them, the cosmos would be lifeless and dull, a void of nothingness. Electrons bring life to our universe, lighting up the galaxies and making life as we know it possible. These little particles are the building blocks of atoms, the most basic units of matter. They are the infrastructure upon which everything else is built. Atoms make up every single thing we see, every object we touch, and every sensation we experience. They comprise the air we breathe, the water we drink, the food we eat, and the very bodies we inhabit. In essence, atoms, and by extension electrons, are the fabric of our existence. Everything in our world, from the microscopic to the cosmic, is made up of atoms. Each atom, in turn, is made up of a core or nucleus, ringed by a cloud of electrons. This is reminiscent of a mini solar system, a universe in miniature. Picture it as a microscopic cosmos with the nucleus acting as the sun, the heart of the system. Around this nucleus, electrons dart and spin, much like planets revolving around the sun. They have a precise path, a predetermined orbit, their movements dictated by the laws of physics. Electrons are a testament to the beauty of the universe, a symbol of the intricate complexity and simplicity that coexist in the cosmos. Their existence, though largely unseen, is felt in every aspect of our lives. From the static electricity that makes hair stand on end to the lightning bolt that brightens the night sky, electrons are the silent puppeteers pulling the strings of the universe. So the next time you witness a balloon sticking to a wall after rubbing it on your hair, or see a lightning bolt illuminating the night sky, remember the immense world of electrons. Their dance of energy paints the universe with life and lights our existence. Think of it like a mini solar system with the nucleus as the sun and the electrons as planets whizzing around it. Moving on to the properties of electrons, they possess a fascinating characteristic, namely a negative charge. This unique attribute renders them an intriguing subject of study in the vast field of physics. It's critical to understand that with similar charges repel each other, while those with opposite charges attract each other. Just like in our everyday life, the adage "opposites attract" holds true even in the microcosm of the atomic world. To give you a more tangible example, let's consider the simple act of a balloon sticking to a wall. This might seem like magic to a child's eyes, but it is in fact the manifestation of the negative charge carried by the electrons. When you rub a balloon against your hair, the friction caused by this action leads to the transfer of electrons from your hair to the balloon. As a result, the balloon gains extra electrons and becomes negatively charged. Now, the wall in our scenario is either neutral or positively charged. Following the principle of opposites attract, the wall is attracted to the negatively charged balloon. Thus, the balloon sticks to the wall, demonstrating a fascinating application of the negative charge of electrons in our daily life. Furthermore, the significance of electrons extends beyond the realm of static electricity. Electrons are not only responsible for the static cling we observe, but are also fundamental contributors to the dynamic force that powers our technology, electricity. The movement, or the of electrons from one location to another, often through a conductive medium, results in the generation of an electric current. Imagine the electrons to be a river flowing through a valley, which in this case is the wire. The river, or the stream of electrons, powers generators, which in turn produces electricity. This is the same electricity that lights up our homes, powers our gadgets, and drives our industries. When you flip on a light switch or boot up a computer, you are essentially orchestrating this movement of electrons, resulting in an electric current. In fact, the entire digital revolution driven by this simple yet profound movement of electrons. And to think, All of this is made possible by these minuscule particles, the electrons carrying a negative charge. The electric current is just a stream of electrons flowing through the wires. Moreover, electrons have a property known as spin. This can be a slightly puzzling term to many, primarily because it immediately conjures up images of a tiny particle rotating on an axis, much like the planet Earth does on its own axis. However, this is not the correct interpretation in the context of quantum physics. The term spin in quantum mechanics is a somewhat abstract concept, different from the usual sense of rotational motion we observe in our everyday lives. It is necessary to delve deeper into the world of quantum to fully comprehend what spin truly represents in this context. Quantum mechanics is a branch of physics that deals with phenomena on a very small scale, such as that of electrons and other subatomic particles. It's an incredibly complex and intriguing field, providing us with insights into the strange and wonderful world of the very small. In quantum mechanics, spin isn't about physical rotation. Instead, it's a type of intrinsic angular momentum, a characteristic inherent to all elementary particles. Angular momentum in simple physics can be thought of as the quantity of rotation of a body. In quantum physics, however, the particles don't necessarily need to be physically rotating to momentum. This is a significant difference from classical physics, which only considers angular momentum in terms of physical rotation. Electron spin, or more accurately, electron intrinsic angular momentum, is a quantum property, meaning it arises from the laws of quantum mechanics. It's quantized, meaning it has a specific and discrete value, and it's an inherent attribute of an electron, much in the same way as its electric charge. The concept of spin becomes even more interesting when we consider that it can exist in one of two states, commonly referred to as spin up and spin down. This binary nature of electron spin is a key aspect of quantum computing, a pioneering promises to revolutionize technology. This property of electron spin is not just a curious characteristic of quantum mechanics, it's a fundamental element of many technologies that are integral to modern life. One particularly significant application of electron spin is in magnetic resonance imaging, MRI scanners. These machines, which are used in medicine to create detailed images of the human body, operate based on principles that hinge on understanding and manipulating electron spin. Without this understanding of quantum mechanics and the spin of electrons, such advanced technology would not be possible. Therefore, despite its confusing name, electron spin is an essential property. It doesn't mean they are spinning like a top. It's a quantum property, which is a completely different realm of physics. But this spin is crucial to many technologies we use today, such as MRI scanners. In summary, electrons are tiny particles that make up atoms. They carry a negative charge, which is why they can create electric currents and cause a balloon to stick to a wall. They also possess a quantum property called spin, which is fundamental to certain technologies. So the next time you see a lightning bolt or a balloon sticking to a wall, remember the unseen world of electrons. They may be small, but they play a big part in the universe. Understanding electrons is not just about understanding physics, it's about understanding the world around us.